So I don't have slides for this panel. I do have some slides. I have another time slot tomorrow, so I'll save my slides for tomorrow. So for those of you who don't know Adaptrum, Adaptrum is a Silicon Valley-based company. We are the first small company to work with FCC, help pass the TV white space rulemaking in the States. We have the first FCC certified TV white space system. We're the first company to light up a TV white space link in Africa. We're the first company to light up a TV white space link in Latin America, in Uruguay, actually, with Paul Garnett, who sits in the back. So we have done quite a bit and have gone quite a long way together with DSA to promote TV white space, to bring the technology to commercial reality. In terms of some of the new things we're going to do in the upcoming years, so we are actually invest millions of dollars to build a silicon for TV white space. That's going to be based on 802.22. That's going to be combining 4 channels and deliver throughput to be more than 100 megabit over TV white space. We're also working with MediaTek and Aviacom to integrate a 802.11 AF solution into our TV white space product. So we will be offering a multi-standard TV white space product in the coming year. We are also working on a few other innovations, in terms of cloud-based management, dynamic resource management, and all that. And also, we are, this panel is about new spectrum bands and sharing in a new new regime. We're also looking into 3.5 gigahertz, which sounds like a very interesting opportunity upcoming, based on FCC, the recent rulemaking. Yeah, that's all.
Okay, so I'd like to get back to the questions that I brought up at the beginning, but first, what we need to talk about here is the fact that we're using a database to locate spectrum seems traditionally to indicate that there's spectrum uncertainty. How do we convince the industry that a database is spectrum certainty? Anybody want to take that?
Good question. I think, frankly, I would say seriously, the onus is on our side to prove that it works, right? So TV white spaces in the US is obviously the first real example of that in the US, but it's happening, as my colleague here will explain in a moment, in other places. It is a technology that over time has become refined, and certainly in my experience, at least in the early days of working this issue at the Federal Communications Commission and on Capitol Hill, in the US, we originally had the broadcast industry as sort of the primary opponents because, in fact, they were very concerned about using geolocation databases as the primary means of sort of managing coexistence within these bands or the bands adjacent to where they were operating. And so we spent many years in the labs with the FCC to prove it out, and I think it's fair to say it has proven out. So I think really we just have to deploy these databases. Google has its in the United States. We just got certified by Ofcom in the UK, and so we have to prove it out. We have to put the devices out there, we have to run these databases and demonstrate that they in fact can manage interference, not just in a sufficient way, but actually in an optimal fashion, in a way better than we could do even in the older days with sort of the contour maps and that sort of thing.
So secondary use is secondary use, and you kind of guarantee that you will always have the band. But what you at the moment, the regulators or no one else knows exactly who is using the band and when they are using. But after these new geolocation databases have been running for a while, there's a lot of statistical data to show where and which statistical characteristics the breaks happen. and by that the information the operators are able to make the risk analysis and kind of build their business so that these breaks during the incumbent use can be tolerated.
I want to add that not only database is working, I think the FCC's database is very conservative in terms of predicting the spectrum opportunity. We have thousands of radios deployed, and what we see in the field is that we actually have sensing capabilities in these radios, and we can see that whenever FCC said this channel is available, it is available. In the case that they said the channel is occupied, oftentimes it's actually available from from an actual measuring perspective. So I think we encourage FCC to improve their model further.
One other point I would make is in the 3.5 gigahertz proceeding I mentioned previously, we have the U.S. Department of Defense, which obviously, their primary task is securing the country, agreeing to an approach that will protect them using a database system. So I think also having the buy-in of major players like the U.S. government and Department of Defense in this case also will help pave the way for others in the sector to understand and realize the value of these databases.
So how do we make a mass market that, equivalent to what Wi-Fi has today? Do we depend on data that we can show in the coming few years that this works and folks can actually have access? In the discussions that I've had with the industry, they always point to New York and Los Angeles and Chicago, and the question is, will these systems work there to a level that will allow for sufficient usage?
So the challenge here is that the first big use cases are going to be with TV white space, apparently. And TV white space has had, unfortunately, a relatively long and rocky history. Despite the support of key policymakers in the United States, I got involved in this issue back in the mid-2000s, around 2004 or 5. The first FCC rules came out in 2008 after several years of very concerted lobbying on all sides. We had a reconsideration in 2010. Then we had Congress step in to do, in 2012, the legislation that's now led to the incentive auction process that's happening today in terms of auctioning off a number of the bands of the 600 megahertz area. So during all this time, the regulatory uncertainty, both in terms of whether white space would even be out there in any sufficient capacities, particularly in the larger so-called NFL cities in the US, plus the fact that these parameters were changing through reconsiderations and petitions filed by various players, really meant it was really difficult for anybody who didn't have deep pockets to want to step into this arena and invest. So there are some that have. Jim Carlisle's here, and his folks at his company have done some amazing things. We should see a lot more to that, but the challenge is we need the regulations to settle down. We need enough certainty out there so the market can start to respond, the technologies can be deployed, and then we can actually see the databases working efficiently.
So at the moment, what we need is demand in the countries where the regulation is in place, and how to create the demand is to targeted marketing and sales activities to potential users of TV whitespace and other shared spectrum users. And so far, quite a lot of the public kind of common events where all the manufacturers and database providers and other stakeholders are doing have been kind of promoting regulation and trying to change the regulation. But we should kind of concentrate also in the countries where the regulation is in place and try to get the demand growing, and that way get the business kind of prospects.
So I think one major barrier is cost. So we realize that our product today, we only have shipped thousands of radios out in the market. So because of we don't really have that volume, the cost is not really there, and most people have been telling us hey, you guys are not competitive in cost compared to the existing Wi-Fi product on the market. So, to answer that, as I mentioned earlier, our company is investing millions of dollars to building this four-channel ASIC which is going to deliver, the throughput that's required. It's going to be doing more than 100 megabit, and then the cost-wise, it will dramatically reduce the cost to on par with any Wi-Fi product on the market. So I hope that with that, we will really, accelerate the market adoption of TV white space. Another thing I want to remind people is that, Wi-Fi, look at Wi-Fi, right? Wi-Fi rules was adopted in 80s, and it's not until 1999 or around 2000 timeframe when Aceros comes with the chipset, Wi-Fi chipset, that, Wi-Fi really took off. So any wireless technology really takes some time to become mainstream. So I believe TV white space has huge potential. I think, in the next year, you will see a lot of movement.
Okay, I have one more question here, and then I'll ask some questions, see if there's any questions in the group. And I wish I had Robert Wu on the panel for this one. But is the ability to have agile radios that could play in any of these bands going to be helpful in the future in making this a successful technology? Ms. Roberts?
Yes.
Yes, the answer is yes, okay.
So as I mentioned, that we're also looking into 3.5 gigahertz band. So the technology we're developing is not necessarily tied specifically to white space. So I think 3.5 can play an interesting role in urban setting where you have smaller cells, you have population concentration. So we're certainly, after we kind of make sure the TV white space is taking off, we will take a hard look at other spectrum bands also.
Okay, with that, I'll ask, are there any questions in the audience for this panel? Richard.
So I was interested in what Haiyun was saying about the cost of the current product and how long it took for Wi-Fi to go from the rules being adopted to products in the market. Now, one of the things that drove Wi-Fi was high-value use cases. So I think it was cash registers, NCR, that led to some of the first volume for Wi-Fi. So where do people on the panel think that TV white space, even with the current high cost, where are you seeing, in which kinds of industries are you seeing that demand for your first radios that you're making, and how will that evolve over time?
Some specialized applications that are usually less price sensitive, like oil refinery, some kind of machine-to-machine communication, tractors. I think because of the cost of the equipment itself, so connectivity become a small part of it. So I think these things probably will be less cost sensitive. But as I said, I mean, really to be able to spur the demand and then really to create the demand, I think, we do want to get the product to the cost point of Wi-Fi products on the market today. And we're not far, really. I mean, I think we're really talking about a year. Within a year, you will see things like that. So don't hold your breath.
In our case, the first deployment was for the ferries in Orkney Island, so north of Scotland, and kind of showing that application has created a lot of interest in other marine area industries as well.
Yeah, I was just going to add, I think it's going to be a combination of factors. One is going to be the niche use cases coming together. The Internet of Things could be one interesting area of that, smart grid, agriculture, transportation. I think there are a lot of places where that can then happen. And then all the way on the other side, the mass market. In the United States, at least, you're seeing the cable companies, I think, making a big bet on the notion of unlicensed as opposed to licensed spectrum. So to the extent they start adding TV white spaces to their portfolio to extend the reach of their coax networks, that could be a real bump in terms of use cases, mass market approaches there. So you might see sort of a convergence between the mass market side on the one hand and then the niche cases sort of proliferating on the other side.
And just for Haiyun, I remember back in the early days of Wi-Fi, I was at Compact Computer, and our challengers said that the price of a Wi-Fi chipset would never be under $100. So I guess you have a point. Okay, any other questions from the audience? Okay, any other comments from the panel before we go? No. Okay, I think we're done, and we can...
You guys are doing your traditional photo.
Una foto, por favor, sigue sacando una foto. Muy bien, mirando aquí, por favor. Una más.
Okay, right. Thank you, Richard, and thank you, the panel. All I've got now is I'd just like to do a quick wrap up for today, and then point out to some of what we've got for you tomorrow. Again, I want to thank you very much for being in Colombia with us, in Bogota, Colombia today. We don't take any of your attendance here for granted. You could be in one of many other places to spend your time. But just doing a recap for today, I just felt that it's been fantastic. I know I'm biased, but I think it's just been fantastic. So let me just tell you why. Just going through the morning, we had a really heavy